Welcome to Dynamic Coaching Center. So, as we are discussing with the Staff Selection Commission JEE previous year past question papers, particularly related to thermodynamic properties. So, we'll start with our next question. So, it is said that heat is being supplied to a system which equals to the work done. Case of non-flow process, which is a closed system carried out at. So, what type of process is a one where your Q and W will become equal? For a process, first law of thermodynamics is equal to Q is equal to del U plus W, right? So when Q and W can become equal, your del U term should be equal to 0. What is your del U for a perfect gas? According to Joule's law, we know that it depends only on temperature, which is nothing but mCv T2 minus T1, right? So this can become 0 only if this two are equal. T1 is equal to T2. So which means I can say that it should happen at isothermal condition. So for isothermal condition, I can say that my heat and work are one and the same. So this is practically impossible to achieve this isothermal process. So that is a process where your Q and W will become equal. So option C is the correct answer. So let's move on to the next question. So neglecting the changes in potential and kinetic energies, the shaft work during steady flow process is given. So it is given as flow process. So it should be an open system. So they have given that it is a steady process, so it does not change with respect to time, and they are asking you to neglect the potential and kinetic energy terms. So generally, if you go for steady flow energy equation, you will end up with these terms. Like for example, you will have enthalpy, kinetic energy, potential energy, heat in plus W in. These are all the possibilities. Similarly, for the second state, you will have H2 plus C2 square by 2 plus G Z2 plus Q out plus W out. These are all the different possibilities that is applicable for any flow process, right? So they are asking you to find out an expression for shaft work during the steady flow process. So see, generally the work done will be equal to VdP. So there should be some pressure change. Okay. And you should also include a negative sign for this. So I can say that the option which is correct is option B. For a shaft work, for any open system, you can apply this law, this equation, integral BdP. How you are applying integral PdV for closed system. Similarly, for open system, you can do this. So we'll move on to the next question. So this question was asked in the year 2014, set 1. So the boiling and freezing points for water are marked. So this is a famous question which has been asked in engineering services exam many times. Boiling and freezing points for water are marked on a temperature scale as P and 130 degree P. Boiling and freezing points for water and minus 20 degree P respectively. So what will be the reading on this scale corresponding to 60 degrees Celsius on the Celsius scale? So they are following a temperature scale as P. Like for your example, you have Rankine, you have Kelvin, Fahrenheit, something like they are following some P where the boiling and freezing points for water has been given as 130 degree P and minus 20 degree P. And they want you to get the reading on this scale for 60 degree Celsius. So you have been given with four options. Option A 60 degree P, option B 70 degree P, option C 90 degree P, and option D 110 degree P. So let me just draw a diagram. Whenever you have been asked with this question, then you can draw this diagram so that it would be easy. So this is degree P scale. And as per this, you have been given with the freezing point as 20 degree and boiling point as 130 degree P. And you also have degree Celsius where you have standard boiling point as 100 degree and this is your 0 degree. Now, somewhere between here, you will reach your 60 degree. And what would be the corresponding value in the P scale is what they are asking. So what I can do is, I'll just use this common difference as a ratio and then try to evaluate this. So I'll put 60 minus 0, which is this difference, divided by this difference, 100 minus 0, should be equal to, since I don't know this P, I'm just keeping it as P itself. The same thing I have to do here. So here I have done 60 minus 0. So here also I should do P and 20. But it has been given in the question as minus 20. So it is P minus of minus 20 by this difference I have to put, which is 130 minus of minus 20. So if I again evaluate this, so it is 60 by 100, which would be equal to P plus 20 by 130 plus 20 will be 150. Just do the cross multiplication and keep P alone on one side of the equation. You will be getting P answer as 70 degree, which means option B is the correct answer, 70 degree. It's a standard question which has been asked in engineering services and ISRO. So we'll move on to the next question. So as you can see that nowadays these questions are becoming tricky. So a closed balloon containing 10 kg of helium receives 5 kilojoules per kg of heat. It is actually receiving heat. During this process, the volume of the balloon slowly increases by 0.2 meter cube. It actually increases by 0.2 meter cube at constant pressure of 100 kilopascals. The change in internal energy in kilojoule is what is del U. So four options have been given. Option A 10, option B 20, option C 30 and option D 70. So we have been given with the mass of the helium as 10 kg and heat received Q, it is plus 5 kilojoule per kg, and change in volume, because the volume increases by 0.2 meter cube, it has been said, and pressure is constant and that value is 100 kilopascal. Okay, so here it is given in the question as the total mass is 10 kg, but the heat is being supplied as 5 kilojoule per kg. So if I multiply this with the mass, then I'll be getting the total heat, which is 50 kilojoules, right? Similarly, you can apply your first law of thermodynamics, Q is equal to del U plus W, right? So it is said that this is constant pressure process. So I can say that my work done would be P into V2 minus V1, which is nothing but P into del V, dV or del V. This del V value has been given and pressure has been given. So I can say that my work could be 100 into 0.2, so which is 20 kilojoules. So I know the heat value, I know the work value. This is 20 and this is 50. So my del U answer would be 30 kilojoules. So if I get back to the question, option C 30 is the correct answer. So let's move on to the next question. So a gas in a container A is in thermal equilibrium with another gas of same mass in the container B. If the corresponding pressures and volumes are denoted by the suffixes A and B, then which of the following statement is true? So there is a gas in a container A which is in thermal equilibrium with another gas of same mass in the container B. If the corresponding pressures and volumes are denoted by the suffixes A and B respectively, then which of the following statement is true? So you have been given with four options. Option A, it is PA not equal to PB, whereas VA is equal to PB. Option B, it is PA equal to PB and VA not equal to VB. And option C, it is PA by VA should be equal to PB by VB. And option D, it is PA VA should be equal to PB VB. This question was asked in the same year 2014, set 1. So let's get into the solution. So we have been given with two statements. So it is clearly said that they are in thermal equilibrium with each other. So I can say that my TA is equal to TB. And one more clue has been given in the question that mass of A gas equal to mass of B gas. In both the containers, the mass remains same. Okay. So we already know that PB equal to MRT, right? So I can say that this is already a constant. Now this is also a constant. This is also a constant. So I can say that PV by T is equal to constant. Or I can say that PA VA by TA should be equal to PB VB by TB. And already we know that this is constant. So this can be cancelled out. So I can say that PA VA should be equal to PB VB. So option D is the correct answer. Let's get into the next question. In an isothermal process, the internal energy, what happens to the internal energy? Okay, so it's very simple. Uh, Option A always increases, option B always decreases, option C increases or decreases, option D remains constant. This question was also asked in the same year 2014, set 1. So we know that in an isothermal process, the temperature is already a constant one, right? And internal energy, we know that it is also a function of temperature alone. So internal energy definitely remains constant, because for a perfect gas, according to the Joule statement, internal energy is a function of temperature alone. But for this process of isothermal, temperature is already constant. So internal energy, which is also a function of temperature, is going to be constant. So I can say that option D would be the correct answer. So let's move on to the next question. An adiabatic process in a thermodynamic system is a one in which there is, so we have been given with options. Option A, a limited heat transfer to or from the system through the boundary. Option B, no heat transfer to or from the system through the boundary. Option C, no energy transfer at all to or from the system through the boundary. Option D, no internal energy change in the system. It was asked in the same year 2014, set 1. See, basically, if you take the adiabatic process of a thermodynamic system, it is a one in which there is no heat transfer to or from the system through the boundary, but work transfer can definitely take place through the boundary. So I can say that option B would be the correct answer. No heat transfer to or from the system. So let's move on to the next question. For an ideal gas, the compressibility factor is option A, some finite value greater than unity, option B 0, option C exactly unity, option D infinity. So this question was asked in set 2 of the same year 2014. So if you know the compressibility factor for an ideal gas, then it is fine. So compressibility factor is the measure of deviation from ideal gas. How far the real gas is deviating from the ideal gas. So that is actually PV equal to ZRT. But for ideal gas, we know that the equation is PV equal to RT. So for ideal gas, this compressibility factor Z should be equal to 1. So which means option C is the correct answer. So we'll move on to the next question. So this is one more similar type. Which one of the following is an extensive property? Depends upon the extent of the system. Option A, temperature. Option B, pressure. Option C, density. And option D, enthalpy. We know that this is an intensive property. This is an intensive property. This is an intensive property. This is the only thing which is a total energy. Since it is not a specific thing, so it is an extensive property. So option D is a correct answer. So we'll move on to the next question. For a closed system, the difference between heat added to the system and work done by the system is equal to. So it is a very simple thing. So you know already the first law of thermodynamics, Q is equal to del U plus W. For a closed system, the difference between heat added to the system and work done. So bring this W to the other side of the equation. So Q minus W should be equal to del U, which is nothing but internal energy. So option C is a correct answer. It was asked in the same year for set 2. So we'll move on to the next question. The process in which no heat enters or leaves the system is called as option A isentropic, option B isobaric, option C isochoric, and option D isothermal. So just now we have seen that the process in which no heat enters or leaves through the boundary is called as reversible adiabatic process. PV power gamma equal to constant. This is otherwise called as isentropic process, or I can say entropy remains constant. So option A is the correct answer. So try solving all these questions and then try to note down and watch this entire series to crack the upcoming SSC JE exam mechanical. Thank you.